Right. Thank you, everybody, and special thanks to Pao and colleagues at the JGI for inviting me for the talk. So yeah, my talk will be about a previous study that we have done using knowledge graphs and also large language models for querying knowledge graphs, and also I'll talk about like our current and next steps in our research. So I hope people will find it interesting because this is a different strand of machine learning and also computational research. So a little bit about me, and as Pao mentioned, I'm based at the MRC-IU, the MRC Integrative Epidemiology Unit under Program 3 on data mining epidemiological relationships. So Pao and I and a previous colleague, we worked at the same team. So some of the works that I'll show today, other colleagues from JGI, including Pao, are also involved in those projects. So yeah, back to this. My main research on the method development and also application of various computational approaches for data mining and public health questions. So those approaches involve data infrastructure, for example, digital platforms, as well as large language models, natural language processing. So the talk the work that I'm going to showcase today is a recent publication that we've done last year called Triangulating Evidence in Health Sciences with Annotated Semantic Queries, or in short, we call it ASQ. Previously, we just want to, make it sound like ask, but it sounds a bit cringy, so now we just call it ASQ. So yeah, for further information about me and my research, you can find it from either my GitHub pages or the MRC-IU GitHub pages. I used to be fairly active in the GitHub organization, but nowadays it's mostly about like CI/CD actions. Yeah. So as a background, so in our group, a previous research that we've worked on is an umbrella project called the EpigraphDB knowledge graph. That involved many researchers in the IU across multiple programs. The idea of EpigraphDB is we curate various evidence from publicly available data, for example, literature and also literature-derived evidence, including SEMADB, and to pair them with the systematic analysis produced by IU researchers. And so we built a knowledge graph with the Neo4j database, and then the whole set of evidence in the database can be queried by the Neo4j cipher language. So, as mentioned, this was published ages ago, and that also lead to various other research that use EpigraphDB, both inside the IU, as well as a couple of citations outside. And also, as the next step that I led on would be something on the use of natural language processing on the querying of EpigraphDB. As you might remember, around that time, that is where what we call large language models now, they kind of take explosive development, BERT and everything else. Yeah. So with the knowledge graph, with the EpigraphDB database and the knowledge graph, we could have various knowledge in various forms. For example, some of them are systematic analysis, statistical analysis by different things. For example, Mendelian randomization analysis, polygen and rescore associations, and other things. So those here, we call them association evidence. And also we have literature evidence, for example, the mentioning of various things from the literature, from the PubMed articles, both in terms of abstracts and full text, and also the further derived evidence from the literature, for example, the SEMAT-DB triples. And also, the other part is how we combine these things together, those different type of entities, biomedical entities, as well as the evidence represented by those entities together. This is via ontology. So the specific ontology we use in the database is called the experimental factor ontology that is being used by EpigraphDB, but also by other major projects in the unit. And so from the evidence, then we can have like a large group of knowledge base or a knowledge graph that are represented by triples, semantic triples in the sense like subjects, predicate, and objects. So those subjects and objects represent like phenotypes, traits, biomedical concepts, and those are mentioned, for example, in statistical evidence, GWAS analysis, and also in Mendelian randomization analysis, and also the mentioning of them in literature. And also in terms of predicates, those could be like a raw mentioning of things like something causes something. For example, what I show here, obesity causes asthma. So that is a SEMAT-DB semantic triple derived from the source literature. Or it could be like a statistical findings, like something is having an effect size on something via a specific statistical analysis. Then, as mentioned, we have a couple of dedicated studies using specific type of research data from EpigraphDB. But can we automate the whole thing? Can we automate data mining and also evidence triangulation in the knowledge graph using a natural language processing method? So this is the work that I'm going to talk about today. What we call the platform that we developed, so the URLs here for people that are interested in. So the ASQ platform we developed, the whole idea is a user input a text involving some scientific descriptions, what we call assertions. So say, can obesity caused by asthma? So that is an assertion where we derive the assertion triple from the source text using some text mining tools that I'll mention in a minute. And then, as mentioned here, this is called SEMRAP. And again, SEMRAP is like a very aged technology that we're hoping to replace at some point in our next step research. And so we derive the semantic triples, assertion triples from the user input. And then from those user triples, query triples, then we harmonize with the various entities available in the knowledge graph. And then we also perform, similarly, we also perform the harmonization of evidence. So by evidence, I mean the evidence triples. So how we compare, say, the concept of obesity with various things, with various data mentioning about obesity in various sorts of data in terms of GWAS data and also in terms of literature-derived data. Then we combine them together, we rank the evidence and then we further group the evidence into various groups to say if we have sufficient evidence to support the claim that, say, obesity can be caused by asthma. And so that is the whole idea, and then I'll dive into details. So evidence triples. Again, as mentioned here in ASQ, we treat an evidence as a semantic triple involving the subject, predicate, and object. So we have a common playing ground to compare the assertion triple, the query triple of interest, as well as the literature, as well as the evidence source from the literature, and also statistical associations. Then we harmonize the quantifiable information and then compare the evidence strength. Again, this is more or less a proof of concept that lead to various future research. So, yeah. Now, how we extract the triple is performed by SEMRAP. As mentioned, SEMRAP is a quite old technology that we're hoping to replace. But ultimately, the benefit of using SEMRAP is that it's also used by this database called SEMATDB that derived triples, semantic triples, evidence triples from the source literature in the dictionary or in the ontology of UMLS. So the UMLS ontology has various terms, canonical terms mentioning various biomedical concepts, for example, kidney and kidney failure, etc., and then also it has canonical relationships. For example, causes, treats, produces, effects. Those have, as you can see, those have a direction, and then there are also non-directional relationships. For example, interact associated with, etc., etc. And how we harmonize the evidence together is done by a previous work where we fine-tuned the Bluebird's language model, what we call language model nowadays. Probably we should call them large language models nowadays. So yeah, we fine-tuned the Bluebird's model with the experimental factor ontology so that it is better able to map the various terms together into the ontology graph. And so so firstly, we scan the whole epigraph DB database in the cached Elasticsearch database, and then we map them together via our developed method using large language models, and then we compare those entities together, and then we have like a common plain ground to compare the evidence in a quantifiable way. Now, those are the list of evidence available from Epigraph DB, where in our current design, we have two families of evidence. One is about the associations involving various systematic statistical analysis, and also the literature-derived evidence that we curate from SEMATDB. And so, as you can see, this is a quite rich source of evidence that we are hoping to continue the development of our knowledge base as well. Yeah. So, how we prioritize the retrieved evidence. So conceptually, it involves two parts, although there are equations, but conceptually, it involves two parts. First is how well, semantically, how well those terms are mapped to the terms of interest from the assertion query in the semantic space via text embeddings. The other would be the strength of the evidence itself. So for literature-derived evidence, it's simply the number of triples that occurred from our curated data in the knowledge graph. And for association evidence, here we simply use a normalized effect size. And I would love to hear about people's comments in our next stage development for this. As I said, this is fairly like a proof of concept. And so, as mentioned earlier, we group the retrieved evidence into several groups. In general terms, for example, if our retrieved evidence are directional and it has sufficient level of strength, for example, the number of literature supported or the good enough normalized p-value, and then we think like we have sufficient level of supporting evidence to support the assertion. On the other hand, if we have evidence from the other direction with also sufficient strength, then we say, hey, here are the evidence that are going to contradict with your claim. Similarly, we also present the evidence of absence in the knowledge graph, in the sense that we scan the whole knowledge graph, and then we also show the user that we found those evidence without sufficient strength, and then to show you that maybe we don't have that evidence, or rather we have the evidence of absence for that sense. So similarly, we have evidence regarding like non-directional relationships. So so in summary, the whole idea of the ASQ research is that this is a query interface to a knowledge graph of heterogeneous type of data evidence, that we derive an assertion triple or a claim triple, as I show here, and then compare with the evidence from the knowledge graph, where the evidence from the knowledge graph are harmonized via semantics and also large language model embeddings, and then they are grouped into various evidence sources to compare whether we have like supporting evidence or contradictory evidence. So here I have briefly described our work, and as you can see, there are lots of things that can be extended from this proof of concept. And also, probably everyone knows, like the AI or the large language model landscape have substantially evolved since like 2-3 years ago. So what's next? So we recently got a Roche-funded partnership on improving the assertion recognition in biomedical literature. So this is more like an applicational type of research that we have recently appointed a PhD student to do the work. So we will be collaborating with other colleagues in the university as well as colleagues in Roche for the various research in this area to ultimately support like how we rank and filter new literature to find like the literature of true of sufficient strength according to pharmaceutical user needs. The other side is we also have a more method development focused PhD that we recently got a PhD that is likely to start this September, that we will be working on the automation of various processes in what I have described, particularly in terms of evidence triangulation. So that will be to apply the LLM and also retrieval augmented methods to perform filtering and screening of candidate studies, and also to extract various data and evidence for different type of research questions and also study types. And also we hope to develop our own method in terms of extracting evidence from tables and supplementary material based on the intent that we mentioned in the main text. So yeah, I just would like to thank everybody involved in the previous project, including yourself as well, and then also other colleagues in the university and our colleagues at Roche. So yeah, thanks for listening, and yeah, let me know your thoughts.